Hi everyone, welcome to my YouTube channel. In this video, I am going to explain you about the experiment on dielectric constant of PZT. So in this experiment, we have to determine the Curie temperature of the ferroelectric material, that is PZT, and the dielectric maxima of PZT. So here we kept the PZT sample inside the furnace. And here we can vary the temperature, and that is temperature indicator. So this is the cubic perovskite structure of PZT, lead, zirconium, titanium oxide. So the hysteresis curve for this material, we can see of domains. So before starting the experiment, we should write the observation here. Least count of screw gauge, that is 0.001, and diameter of the sample, it is about 2 centimeter, the PZT sample diameter. Radius you can calculate, that is 1 centimeter. Thickness of the sample using screw gauge you can calculate 0.17 centimeter. Area, if you know the radius, you can calculate area, that is pi r square, 3.142 centimeter square. So permeability of the free space, standard value 8.85 into 10 to the power minus 12, you can write. And formula to calculate the capacitance, that is epsilon naught epsilon r into area divided by time. So here relative permittivity, that is given by Ct by epsilon naught A. So then this C divided by C naught we can take. This is not epsilon naught, C naught. C by C naught ratio for epsilon r. So C naught is here, from that equation we can get epsilon naught A by T. So if you substitute all the values here, you will get the capacitance of air or for free space, that is 0.00163 nanofarad. So the nature of graph for this experiment is given here. You have to plot the graph of epsilon r versus temperature. So this peak is nothing but relative permittivity. So the kit consists of 2 plates of conductors, one above and one below. You can see in this kit, so the plates we can see one above and one below, having circular area A, and the white color we can see, that is what the sample PZT, having the same dimension. A sample with same area of plates is introduced between the plates. This arrangement consists of capacitor with sample PZT and dielectric medium. So the setup is placed above the furnace. So the setup is above the furnace for heating. A thermocouple is kept in contact with sample to measure the temperature. As the temperature increases at suitable value, the capacitance value are noted using capacitance meter. So here is the Kepler column. We have to heat the sample up to 400 degrees Celsius. So for cooling we have to note down here. So you can start from 395 degrees Celsius and you can take up to 280 degrees Celsius. Okay. Then capacitance, second column, capacitance you should note down from the capacitance meter. And the dielectric constant formula, that is epsilon r is equal to C by epsilon naught into 10 to the power 3. So C naught value we have calculated here. Put that value and you can calculate ratio C by C naught. So this is the graph of epsilon r versus temperature in degrees Celsius. So once we plot, we are going to get the peak. This peak corresponds to the maximum relative permittivity. So it is about 17.91 into 10 to the power 3. You can write the result here. So the Curie temperature of the ferroelectric material is how much? 355 degrees Celsius. So this peak is observed at 355 degrees Celsius. Dielectric constant of the given material, that is maximum epsilon r 17.91 into 10 to the power 3.